what we're going to be looking at is mostly looking at the properties of those groups. We're going to do a little bit more work today on understanding how the periodic table works in terms of trends and kind of what that means just in general. That when you guys are looking at things on the periodic table, it's kind of important that you understand what those things are and how they work. So with that, let's actually move right into the first group, who are alkali metals. Who had that? All right. First, Chloe, why don't you tell me, which group is the alkali metals?
This first group over here.
All right, so our alkali metals is basically going to be this right here, right? So this is alkali.
Yeah.
No, not what I wanted.
That sucks.
Hey, come on.
Sorry.
Alkali. Okay. Which is different from the alkalins, right? So these are the alkali metals. All right, so tell me about it. You go up to the front, tell the class about them, or just tell me something you guys know, and I'll write them down and you just tell us. So alkali metals. Sure.
Alkali metals are in group 1 of the periodic table. They react harmoniously with water and these types.
All right, let's stop there one thing at a time. So they're group 1.
Right.
Do you react heavily with water?
Yeah.
And what does that produce? It produces hydrogen gas. Okay. All right, what else did you find out about these?
In the air, alkali metals tend to cover their surfaces with oxide.
All right, so we get easily corrode.
Yeah.
I mean, that's really what an oxide is. It's literally corroding away at the metal. Okay.
They are also found in ionic compounds, but never in their pure states.
Okay, so we never find them in a pure state. Okay, now, remember yesterday we talked about sodium, the fact that sodium was really soft, you cut through it with the butter knife, and the fact that it readily explodes in water. Like, let's see that. All right, well, it'd be kind of neat to see, but here's the problem. Just like what Cole just told us here, you're never going to find it in a pure state. So what they have to do in order to get sodium is they have to find something else that has lots of sodium in it, and find a way to extract that and actually get pure sodium. And that's not an easy process. So sodium is actually very expensive, despite being pretty abundant. Actually, relatively expensive.
Well, that's not a good answer.
No, you
Sorry, I don't know the prices of all the metals in the periodic table. Okay, give me something else.
The alkali metals tend to lose one electron and form ions with a single positive charge.
All right, so we lose one electron. And we have a positive charge. All right, and I'm looking at some. What is a common physical characteristic of these? A physical property that they all share. What color are they? So they tend to be gray or silvery in color. All right, so that might be something you guys want to write down. They tend to be gray or silvery, and they're very soft. And we're just talking about the fact with sodium, you can actually cut through sodium with a butter knife. So they're very soft metals, tend to be gray. So, they react heavily with water, right? You guys want to see that?
Yeah, we do. Can we see it?
Oh, we're going to see it.
Oh, this doesn't
I've
count.
seen this before. Watch this in chemistry.
That's awesome.
You can appreciate the sheer fun, mayhem that chemistry can be. There's so much to it. Bunsen burners, mixing chemicals. Very nice. Now,
Hey, we did
you
that.
may have been allowed to mix very small amounts of lithium with water. You may, if with a responsible adult, have mixed H2O
That's
with
not
sodium.
responsible at all.
And you may, under very strict scientific control, have witnessed potassium mixed with water. But the odds are, if you have, it will only ever have been on one of those rubbish science videos. There you go, mate. Present. These next two are the dog's nuts of the periodic table. They are, if you like, the king and queen of our planets. Mix these babies with water, stand well back, and watch the mayhem. And that's just what we're going to do. Mr. Tickle, bring on the rubidium.
Here it is.
Is that it?
Well, it
what's
might
the
not
close
look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions, just for safety.
Right, so what's going to happen when you drop that in the water?
What gas is inside there?
Argon. No.
No, he said R.
Terry.
Mars?
No, not sodium. What gas is inside there?
Argon.
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 Sounds right.
What type of gas is argon?
A noble gas. That's a noble gas.
That's a noble gas. So we talk about noble gas, and we're going to come back to this. By the way, this is rubidium. Guys, look at your periodic table. How far down is rubidium? How far down that list?
Pretty far. Somewhat.
All right, it's almost down to the bottom, right? Okay. The more you go down that list, the more reactive that becomes. So the farther we go down group 1, the more reactive that we get. So here we go.
Well, imagine, if you will, letting off a hand grenade in a bathtub.
Righto, I'm off.
Remember, this is just
Okay.
a tiny little vial. Look at the size of that. Just an itty bitty vial. of
Okay,
rubidium.
Tickle, drop the rubidium in the water.
Stand back, everybody, this one's going to be bad!
2 grams of rubidium will only react when our specially designed
2
vial
grams.
dissolves in the water, which gives John a few crucial seconds to get into our safety zone. Yes! Whoa, that is more like it. Only on Brainiac do you get that kind of sign.
Why did that explode?
Oh no, we're reacting. Because it reacts with
So why did it explode?
the balance of
Somewhat. What it's literally doing is it's reacting with the water, and what you're going to get as a residue is a rubidium oxide, right? You just talked about oxide, it's like a rust that covers. Alright, so the pure rubidium is going to mix with the oxygen in the water, and what that does is that the sudden release of all that hydrogen gas. That's the explosion you're seeing. The big whoosh of water coming out is because the hydrogen gas is immediately being released. Remember yesterday we did that little lighter thing? We split the water and we lit the hydrogen gas on fire? Okay, we got this pop. That's literally what's happening here. You have such a sudden release of the hydrogen gas that all the water gets pushed out in the bathtub. Now that's rubidium. What's next on that list? Cesium. Cesium. That's, again, pretty far down there. Let's see what happens when we put cesium
But
in.
I believe we can go one better. There is one more alkaline metal we can really use.
Yes, Richard, cesium, the emperor of alkali metals, particularly nasty to go off at any time.
And that's it.
Oh, yes.
I like it already. Now, what's that going to do when it hits the water?
Imagine a depth charge in a bathtub.
Fair enough, mate. I'll be sure it's good.
Thank you.
Okay, John, go for it.
Warning, 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 extreme danger, clear the area.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion. And it does. Magnificent. And I think that concludes today's experiment. There is, I should say, one more, even more reactive metal, francium. But for some reason, they wouldn't let us have any of that. So, there you go. Today's lesson.
Never mix alkali metals with water.
There we go.
I love that. Click on the balloon. It's a slow-mo guy.
Alright, so, alkali metals readily react with water. You get a release of hydrogen gas. Bad things happen. We get a big explosion. That's your alkali. Alright, who had alkalins? Alright, what can you guys tell me about the alkaline metals?
Alright,
The metals are beryllium, magnesium, calcium, strontium, barium, and radium.
Alright, so that's basically going to be group 2, right?
Yes.
So that's our alkaline.
And they are in the S block of the periodic table, which is groups 1 and 2. And then sometimes hydrogen and helium are considered part of that, and that's just like the way the electrons are in the, yeah.
Not sure I fully agree with you on this. Groups 1 and 2 are completely different. You have alkali versus alkaline. Okay, and when we think about alkalines, it is not going to be groups 1 and 2 together. That's why group 1 is the alkali.
I just said the S block is groups 1 and 2 together.
Yeah, and see, okay, well, and somewhat of that. S block is really, I guess it's, yeah, somewhat of group 1 and group 2. Let's go back to that here. The right slide. So your S block is kind of with groups 1 and 2, but I want to know more about group 2. What are some of the common characteristics that we have here in group 2?
They are harder and denser than sodium and potassium. They have higher melting points. They are a shiny, silvery white color.
All right, let's stop it there. So we have high melting points. They tend to be shiny and silver. Right, tend to be silver in color, so you get more of a shiny silver look to them. All right, what are some other things that you guys picked up on?
They are the high reactivity series of metals.
Are they as high as the alkalis?
No.
So remember that with the alkali, they only had that one electron to give away. So that's why they're so reactive, because they have such a small amount of electrons to give away, they can readily react with almost anything. And so they react very quickly. The alkalins have how many extra electrons?
2.
They have 2 extra electrons. Therefore, they're still highly reactive, but not as reactive as the alkalis. All right, other things?
They have high boiling point and low density.
High boiling point. And we'll say and density. So high boiling point and density. By the way, what are your batteries made out of? What metals are inside your batteries? Lithium and what? Well,
this is like,
I mean, if you think about it, right, the far left that we go, the more metallic we become and the better that these actually are heat conductors, the better they are at being electrical conductors. So when we think about our batteries, we've moved into lithium and nickel, which is actually not in this group. But this is really kind of where we get a lot of our batteries from, especially the lithium-ion batteries. It's because it's so great at the way that it's able to conduct electricity, we actually don't lose a lot of that energy in the transfer there. All right, so do we have anything else there for alkalines? So they're a little more sturdy, a little harder than the alkalis, but not a whole lot more really the same. They're fairly similar. The big thing I want to make sure we talk about is they have a +2 charge, which means they're going to lose 2 electrons instead of 1. They have a +2 charge.